So today, which is the last part of our functions unit before we have our tests. Give me just a second. Let me get it zoomed in. Thank you. It says, I can identify parts of a graph. So today I'm going to teach you the different parts of a graph. We're going to be able to identify them, and it's going to be lovely. Are you guys ready? Okay, guys. Now, I did not say for you to throw these extra sheets away. I said to set them aside so that we can use them as scratch paper. So set them aside, and let's use them as scratch paper. If they're already crumpled up, that's fine. But the ones not crumpled up, let's set them aside and use them as scratch paper. Just make a stack of them.
Wait, I thought we
We're going to use all of it as scratch paper. Alright, so values of graphs. So let's open this. The first thing that we're going to do today is we're going to talk about x and y intercepts. So we're going to draw a function on here, and we're going to identify what the x-intercept is and what the y-intercept is. Now, x-intercept is when it crosses which axis?
Y.
The x-axis, because it says x-intercept. And y-intercept crosses which axis?
Y.
And notice that they labeled our y-axis as f at x. It's the same thing. Isn't it magic?
Yeah.
No. Stop. Alright, so put a dot here on 3, -1. Put another dot here on, -3, 0. And another dot here on 1, 0. And I need you to just stop because you're stressing me. So this is what my graph is going to look like. Do you need another cough drop?
Yes, ma'am.
Are you coughing?
As Keegan showed you on his music, bro, it's good. That boy's music. It's
Alright, so now, x-intercepts are where they cross the x-axis. So that's right here and right here. Y-intercepts are where they cross the y-axis. There's only one of those, and it's right here. Isn't it magic? Alright, so we say that our x-intercepts are at -3 and 1. And our y-intercepts, we only have one of those, and it's at -2. Yes. We're labeling both. We're just calling both of them, so we put it in brackets. If we labeled the points, we would put it in parentheses. The points would be -3, 0, and 1, 0. And the points for the y-intercept would be 0, -2. Put it in the tray, please. But because we're just labeling the actual point, we write it in set notation. Avery, can you please stop talking? Any questions on x and y intercepts? Fantastic. Are you serious? Please put that down. You don't need those anymore. Do you need me to come over there and sit with you like you're 5, or can you handle putting your scissors up? Thank you so much. Alright, line of symmetry. Are we ready?
Yes, ma'am.
So the line of symmetry is where it cuts the graph in half. That means that it's congruent on both, or the same rather, on both sides. So we are going to make our graph have tickies. And I'm going to have 1, 2, 3, -1, -2, -3, 1, 2, -1, -2. I did. I drew my tickies. Isn't it magic? You have the same paper as I do.
The last one had
Right. It's a new page.
This is the process. I'll pay you that.
Okay.
I'll bring some more.
Okay. Thank you. All right. So.
Wait, don't you have to draw a little dot at the bottom?
No, you don't have to.
Oh, you don't?
No.
When do you have to?
Whenever you label the vertex. Alright, so the line of symmetry cuts it in half. Now this line of symmetry is right here at x equals -1. So the line of symmetry crosses the x-axis and it cuts the graph in half. So it crosses the x-axis and it cuts the graph in half.
Oh,
That blue looks like it's glowing. Nothing. Are we ready?
no. Fraction.
So that means that each point on the left is the same distance away as each point on the right. So this point is 2 units away, so this point over here has to be 2 units away.
From the middle.
Yep, from the axis of symmetry.
That's the middle.
Oh my god. If it cuts the graph in half, then yes, baby, it's the middle.
That point at the bottom.
Oh, the green line.
But it's not half. The half is where the one the other one next to it.
Oh, yeah.
That's half.
Alright, next. It's not, baby. This cuts this graph in half. This is the middle, right here.
Are you talking about those lines?
So how do you know?
Of the function. Yes, of the function.
Sorry, I understand now. I know.
What, baby?
How do you know where to put the line on top of half? Like the green line.
In the middle. In the middle. It's literally the same distance from one side to the other. So if this was 3 units away over here, I would count. And you see how I counted to the middle? And I got to the middle? Do you understand that that's the middle? Are you sure? Are you positive, baby? It cuts the graph in half so that it's the same from one side to the other. Okay. That's the point of what we're doing, baby, is to be able to point out parts of it. Sweet Jesus. All right, positive and negative. So what we're going to do this time is we're going to identify the positive parts of our graph and the negative parts of our graph. So this is what my graph is going to look like this time.
So what?
So you draw this function. It's not. It's a squiggly line. Alright, so I'm going to outline the positive parts of this graph in green. And what do y'all want the negative parts to be in? Blue. Okay. Alright, so the negative parts are going to be in blue.
It looks purple blue. Indigo.
Okay, so positive means that it's above the x-axis. So positive is above x-axis. And negative means it's below the x-axis. Now, do you see how it's labeled, the x-axis and the y-axis for us? Okay, fantastic. One person sees it.
I do.
Okay, 2 people. Awesome. Thank you. Now, this part over here, is this above the x-axis or below? Above it. So we're going to outline that in green.
I'm not a color.
You look in the third drawer of your tower and get out some markers. Just like everyone else in the room is doing. Alright, now is there another positive part of our graph?
Yes.
On the right side, correct?
Yes.
Up here or down here? Up there. So let's outline this in green. Now, does it stop at the x-axis? Yes. Okay, pumpkin.
Wait, so the bottom's gonna be blue.
The bottom is going to be in blue. Why is the bottom in blue?
The negative is below the x-axis.
Yes, great job, y'all.
Can I have some point? Yeah.
Everybody can take a point, even though y'all are kind of on my nerves. When are you going? Friday. You owe me some things, so I would check the board over there and see what you owe me. Thank you. All right. Are we ready for the next Flappy?
Wait, Sure. You didn't label the bottom part. I'm not
Hey guys, we need to name.
always on my
I don't think that's how we should describe it.
Just put all.
I have to move you away from me. I'm tired of you.
Maybe you start today. Could just put like
I like your shirt.
All right, so increasing and decreasing. So increasing means the graph is going up. Decreasing means the graph is going down. So let's draw the same function. Please don't die.
I won't.
Alright, so this time I'm going to do increasing in pink, and I'm going to do decreasing in yellowy color. A yellowy color.
I can repeat.
It's okay. Alright, so you read this from left to right. So when you're looking at the graph and you're trying to figure out which one is increasing and which one is decreasing, you read the graph from left to right. So let's write that down. Read the graph from left to right. Every time. You read the graph from left to right. Every time.
I don't want to. Above the egg.
No, you read the graph from left to right.
Left is like.
So from left over here to the right, is this graph increasing or decreasing? It's decreasing. You would fall down this hill and it would stop right here. And once you turn this curve, what would you be doing? Increasing. It's like imagine riding a skateboard from left to right on this hill. And what would happen on the right-hand side over here? Decreasing. For no reason. Yes.
Okay, so you said it's decreasing, and you said it stops when you get to the axis, right?
No, it stops when you get to the bottom.
Okay, then now I'm getting this. Alright.
So this is decreasing. This is decreasing.
Is it?
And this is increasing. So when you're looking at this, whether it has to do with a linear line, whether it has to do with slope, whether it has to do with increasing or decreasing, always read your graph from left to right. So from the left side to the right, that's falling down the hill. You would skateboard, ride down it, and die. Then you would reanimate as a zombie. You would kick up the hill, so that's increasing. And then you would get at the top and you would fall off and die again. Does everybody understand?
You go a little wait. I want to read the graph.
Alright, please make sure that you have this. Read the graph from left to right because that is very, 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 very important. Highlight it, circle it, heart it, baby Jesus, it's something.
Put in a crest star.
You said jagged around it. Alright, last one. Relative minimum and relative maximum. Those are called extrema. So please draw the same graph again. The same one. That's the goal. Alright, so the minimum is the lowest point on the graph. So the lowest point on the graph. Oh, Blair, that's not how you spell graph. That's how you spell graph. So what would the maximum be?
The highest point.
The highest point on the graph. Now, you ignore the parts where it goes on forever and ever and ever, and you look at where it curves. Now, this point right here on the left side, this is a minimum. Because it is the lowest point right there. That keeps going on forever and ever and ever. You don't worry about that.
And then the top one is the maximum.
The top one over here would be a maximum. Because it's the highest.
Okay, this one, I like this one.
Blue and pink. We're going to talk about that mañana. Oh, wait. Extreme. Okay, hang on. Don't leave yet.
No one leaves, or you will be